All right, so section 6.3 is about trigonometric functions and real numbers. So now we're kind of relating everything that we've learned so far. So taking the unit circle and relating it to trig functions. So now we're going to actually use angles and find the trig functions that relate to those angles. So on example 1, it says, what are the sine and cosine of the angle 2 pi over 3? Obviously, if you read that, you're going to be like, I have no clue what to do. So make sure as you're doing this that you actually draw a picture of what's happening, because that's how it's going to make sense. Your unit circle is also your best friend here. So 2 pi over 3, if I look at my unit circle, and I find 2 pi over 3, okay, that's this angle, right? So it's about 120 degrees. You can switch back and forth between radians and degrees, and it's no problem, okay? It won't impede your ability at all. So I know that the angle is about 120 degrees. I'm going to sketch that back on the notes. So here's my coordinate plane, and I know that my angle here, it opens up to 120 degrees, which is right here. And I'm just going to do it in degrees. You don't even need to do it in radians at this point. So how you find the sine and cosine? Well, sine and cosine relates to trig, which relates to right triangles. You're actually going to make a right triangle, okay? So I'm going to go back to black, and I'm going to connect the terminal side down to the x-axis, okay? And now you see there's a right triangle there. Hope we all see that. Okay, so now you got to think about your reference angle again. So remember we talked about previously that this is 180 degrees. The angle we drew is 120, so the degree difference between them is 60. 180 minus 120 is 60. So this would be a 60 degree angle in there. That's my reference angle. And then you can figure out the other angle because all the angles in a triangle add up to 180. So I have 90, that's the right angle, plus 60, 150. To get up to 180, I know the other angle is 30 degrees. So what you've just drawn is a reference triangle. Okay, so this is a reference triangle. There are two special reference triangles, and I'm going to draw them over here. So your special right triangles is what I'm going to call them. And they will come in handy all the time. So the first one is a 30, 60, 90. That's what we just drew. You can draw it any way you want. All that it means is you have a right triangle with a 90 degree angle, the 30 degree angle, and then, not 90, 60 degree should be the other one. So you have your right angle, which is 90, 30, and 60. So this is a 30, 60, 90. The reason that your special right triangles will be important to know is that it can help you figure out specific sides of the triangle. So the way that people came up with the sides of the triangle is, starting with the 30 degree angle, that's your tiniest angle, okay? That's the smallest angle. The rule is that across from the smallest angle is the shortest side. So across from 30 degrees, I'm going to say this one is 1. Based off of that, you can find the other two sides. I'm just going to tell them to you, but you could do this using Pythagorean theorem and trig functions. Across from 60 degrees is radical 3, and then across from 90 degrees, so your hypotenuse is 2. That's always true for a 30, 60, 90 triangle. You also have another special right triangle called a 45, 45, 90. It looks something like this, okay? And both of your angles then are 45 degrees. 45 plus 45 is 90. 90 plus 90 is 180. So across from 45, I have 1. Across from 45, I have 1. If the angles are equal, then the sides have to be equal as well. This then means that your hypotenuse across from 90 degrees is radical 2. And that's always true for 45, 45, 90. The reason we use these two special right triangles is if you go back to your unit circle, you'll see that all of these lines right here that I'm highlighting now, this one's 30 degrees, this one's 45, this one's 60. So those are the only reference angles that you'll really ever have to use, okay? So, thinking about that now. Now, it says, what are the sine and cosine, okay? So, first of all, I'm going to start with, okay, my sine of this angle, so 2 pi over 3, I'm basing that off of this 60 degree angle. Let me highlight it. This 60 degree angle here, my reference angle, okay? Sine, once again, is opposite over hypotenuse. So I'm going to fill in those sides from my special right triangle over here. Across from 30 degrees, once again, is 1. Across from 60 degrees is radical 3, and my hypotenuse would be 2. The only thing that there is a catch as far as applying a special right triangle onto the actual coordinate plane is you have to be aware of negatives. So you'll notice that this 1 along the bottom here, that's actually a negative 1 because it's in the negative direction on the x-axis. Okay, I didn't go to the right. That would be positive. I went to the left. Radical 3 would be positive because it's going up. That side of the triangle is going up. It's above the x-axis, and your hypotenuse is always positive. So my opposite side would be radical 3. My hypotenuse would be 2, based off of that 60-degree angle. Then my cosine of 2 pi over 3 would equal my adjacent over hypotenuse. So adjacent would be negative 1. My hypotenuse is 2. And there's my answer. That's all there is to it. So once you get the special right triangles down, I'm going to draw a little cloud around this because this is very, very, very important information. Once you get those special right triangles down, the rest is easy breezy. Okay? All right, then on letter B, it says, what are the sine and cosine of a 45-degree angle? Once again, refer to your unit circle. Negative 45 degrees now is, there's my thingy. I'm going to actually undo the markings that I've done so far so we don't get so confused. Negative 45 degrees is right here, okay? So I'm going to start by drawing that picture onto my notes. So I have my coordinate plane. And I know that that angle always starts on the x-axis, and it opens up to about there. That's negative 45 degrees. All right? So I'm going to turn this into a reference triangle. All I do is connect it up to the x-axis, never to the y-axis, always up to the x-axis, to form a right angle. So then you think, okay, if my angle here is negative 45 degrees, what's my reference angle? Well, that goes back to what we learned in section 6.1. In this case, this would be a 45-degree angle, which means the other angle is also 45 degrees. So now I'm going to use the info from up here, where I'm drawing the star, for a 45, 45, 90 triangle. Okay? So my two legs of my triangle are 1 and 1, and my hypotenuse is radical 2. I got that information from that special right triangle. The one along the top is positive because it's in the right direction on the x-axis. The one that's going up and down, though, that's below the x-axis, so now that's negative. And once again, your hypotenuse is always, always positive. So now, sine and cosine. So sine of negative 45 degrees. Sometimes people get tripped up on which angle to look at. Make sure you're looking at the inner one. That's right next to the origin, that 45 degrees. That's what we're looking at. So once again, my sine is opposite over hypotenuse. My opposite side would be negative 1. My hypotenuse would be radical 2. There is a catch. Whenever you end up with a radical in your denominator, you have to get rid of it. That is not simplified. We learned that back when we talked about radical form a little bit. Okay? So what I'm going to do is radicalize the denominator. How I do that? All I'm going to do is multiply that fraction by radical 2 over radical 2. So when I do that, across the top then I have negative 1 radical 2. And then across the bottom, I have radical 2 times radical 2. So you can think of that as, okay, that's radical 4, or you could even just automatically say, okay, I'm going to simplify the top to just negative radical 2 because the 1 doesn't matter. Square root of 4 is just 2. So you can either think of radical 2 times radical 2 is radical 4, square root of 4 is 2. Or you can think radical 2 times radical 2, the radical just cancels, and you end up with 2. So there's my sine of 45 degrees. Then I have my cosine of negative 45 degrees, which would be adjacent over hypotenuse. So 1 over radical 2. Once again, I'm going to rationalize the denominator. So I have radical 2 over radical 2. 1 times radical 2 is just radical 2. Radical 2 times radical 2 is just 2, as we just looked at. So that would be my cosine. So you can see that sometimes your sines are negative or positive, kind of depending on what quadrant they are in. Okay, so once again, this triangle would be in quadrant 4. The one we did in example 1, that would be in quadrant 2. So depending on what quadrant you're in, that will affect how it turns out. So now, looking at example 2, this is kind of a different type of problem. It says, what is sine theta if cosine theta equals negative 3 over 5, and the angle with measure theta is in quadrant 3? Okay, so what I'm going to do first of all is just draw an angle in quadrant 3. So I have my coordinate plane here, and I'm going to draw some angle that opens up into quadrant 3. This is quadrant 1, this is quadrant 2, and this is quadrant 3. So it needs to open up here. And it doesn't matter what angle, this is just a visual aid. I'm going to go ahead and draw my reference triangle then. So here's my reference triangle, and there's my right angle. So we know that the cosine of theta would be the angle that's right next to your origin. Cosine is adjacent over hypotenuse. So the adjacent side would be -3, which makes sense because it went to the back, over the hypotenuse, which is 5. So I'm trying to find this missing side in order to be able to figure out the sine. So I'm going to label it x. How do you find the missing side of a right triangle? Pythagorean theorem. Hopefully that rings a bell. So a squared plus b squared equals c squared. So what I'm going to do here is I'm just going to pick one of the sides to label A, one of the sides to label B, and make my hypotenuse C. So I'll say, okay, here's x, so x squared plus my other leg is -3, so -3 squared equals my hypotenuse, which is 5 squared. So to simplify that, I have x squared plus -3 times -3 is 9. 5 times 5 is 25. I would subtract 9 from each side. I end up with x squared equals 16. Take the square root of both sides, and I end up with x equals plus or minus 4. So then you just got to figure out, okay, is it positive or -4? In this case, since that side of the triangle is going down, it's below the x-axis, that would mean that this is -4. So now that I filled in that missing side, I can figure out the sine. So in this case, I'm going to say sine of theta equals my opposite side over my hypotenuse. So -4 over 5. And that would be my answer. That's all you got to figure out. All it asked for was the sine. You don't got to do anything else.